Cool. Welcome, everybody. We're going to talk about Sanoid today. Sanoid is my own platform. If you're a venture capitalist, you would understand it as hyper-converged infrastructure. If you're not a venture capitalist, what we're actually looking at is condensing enterprise virtualization into a single machine using open source software and commodity hardware. My name is Jim Salter. I live in Columbia, South Carolina, and I own a consulting firm there. I developed this platform for my own private day-to-day consulting firm, but the new company, Openoid, is a startup devoted specifically to making this platform available elsewhere. So before we talk about the actual platform itself, way back in 2002, this guy said something to me that just blew my mind. Tim Anderson is director of IT at an insurance firm in Portland. And back in 2002, he told me that the IT hero is dead. He said, the days of the guy who went back in the closet and did the crazy things nobody could understand to resurrect the server that was down at the last minute, that was all over with. He said, we have policies and procedures now. We never have issues like that. If something goes down, you have backup and you follow all your procedures and everything's golden and, nothing's ever weird. And I told him he was insane. Because as a small business, as a consultant to small businesses, I knew that my usual client acquisition process looked something like this. It blows up, I get a phone call, and I come in and I do exactly the IT superhero crap that he said that nobody ever had to do anymore. Now, what I didn't really realize back then was the difference between small business and enterprise. In my world as a consultant to small and medium businesses, keep in mind, this was back in 2002 before virtualization got big. So if you were an enterprise, you didn't really buy a server. When you bought a new server, you bought 2 or 3 of those things and probably enough parts to build another one that got stuffed in a closet, and you had next day service and blah, 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 and all this kind of stuff, so that, when any of these kinds of catastrophes happened that could only be resolved by having another nuts and bolts identical to the last screw server available. If you've ever used Windows NT Backup or Symantec Enterprise Backup or anything else, you will of course realize that you can back up the whole machine, including system state. But if you don't have physically identical hardware, Microsoft will tell you quite clearly, although in very small print, system state restoration is only supported on identical hardware. So in the enterprise, like I said, you just have a closet full of the exact same thing and it's no big deal. In small business, what usually happens is the machine dies and it's 5 years old, and it was probably an old design 5 years ago and it hasn't been made for a long time. And you're hunting on eBay for, a replacement motherboard of the same part and hoping for the best, and everything sucks. Which is why I end up in the back, doing the IT superhero crap and hacking the registry and, performing some kind of miracle at the end. So after you get through all of your IT superhero garbage and you've done the black magic and sacrificed the chicken and the server's up and limping along again, the first thing that the business owner wants to ask you is, well, I don't ever want to go through this again. What does the Fortune 500 do? What's IBM doing? What's Microsoft doing? And, the answer to that is it doesn't matter, because you can't afford to do what they do. Again, all the way on the low end, you're talking about, having literally 3 or 4 physical copies of every server you buy. And if you tell a small business owner that that's what you want them to do, they will throw you out and get a quote from somebody else. So I mentioned that, what we're doing is enterprise virtualization, but we're doing it on a much smaller scale. Smaller in terms of the amount of hardware required, in terms of the amount of dollars that you have to throw out there. So we want these enterprise features. We want the stuff, when the small business owner said, what's the Fortune 500 doing? What he really meant is, I want the kind of predictability and reliability that those guys have. So when I say that we have enterprise features in a small business budget, which features am I talking about? Predictability, minimal downtime, rapid recovery. Now, I feel like it's important to talk about the minimal downtime, because a lot of people want to go nuts about saying, oh, well, I've got true high availability and I've got automatic failover and I've got all these awesome things. And yeah, those things are great. But if you've got automatic failover, the thing that comes along with that is the possibility that both of your redundant devices decide that the other one is down and that they're the real device and they both come online at the same time. And half of your firm is doing, work on one machine and half is doing work on the other. And then 2 days later, you figure that out and you have to figure out how to merge all that stuff from 2 different boxes when nothing works. I don't like all that. So I'm actually okay with downtime in small chunks. If a box is down for 5 minutes or 10 minutes or 15 minutes, generally in my experience, most people are okay with that. Even in fairly big organizations, if it's up again, no questions after 10 minutes, dude, you can deal with 10 minutes of downtime. So I feel like it's important to clear that up. And finally, rapid recovery. That kind of goes again with, yes, it needs to be back up after 10 minutes. If there's an emergency, you need to be able to come back up from it quickly. One of the things that sucks about being the IT hero is, yes, you're doing this crazy black magic stuff, and yes, you're pulling off insane miracles, but half the time you're closeted in the back with a server for 6 hours with no guarantee at the end of the 6 hours whether everything will be fine or mostly fine or sort of kind of limping, but you're really going to have to do something else the next couple of days to get it all the way back up and running, or just you haven't accomplished a thing. I'll let you know when I'm done doing my magic. That sucks. Nobody wants that. So how does the enterprise accomplish these things? Well, there's a diagram. You got a storage area network, preferably 2 storage area networks, because if you don't have a backup, then your data is very temporary. So you need 2 SANs to replicate between the 2 of them, which nobody actually has, by the way, but you need that. And then you've got, Linux boxes over here and storage arrays over here. You've probably got a tape library, and you've got some Windows boxes, and you've got a compute stack, all this complicated stuff. One of my favorite parts to hate on that, the bit down there in the middle on the bottom, your nice 10 gig fiber transport, because you've got this tall storage silo, and you need a separate private network that your users can't touch to get all that from your storage stack to your compute stack. This is a bunch of complicated stuff to set up and manage, complicated and expensive. That's the other way that the enterprises manage all this. And we can't really handle that either in the small business world. So how are we going to do it? Well, we're going to use open source software, and we're going to use commodity hardware. There's no unobtainium here. All of the software is either available from your distributions repositories, or it's available from GitHub, because the parts of it that I wrote are GPL v3. They're up on GitHub. They're available. I would love for you to be my customer and hand me actual money, cash dollars. I like those. But I'm a firm believer that your customers are your customers because they want to do business with you, not because they're locked into it. Getting down to the nitty-gritty, enterprise features. This is the first and the most awesome thing to me, rolling hourly snapshots. What that means is that every hour, on the hour, every single block of data on every single VM that you have is frozen in time. And you can jump back to that instantaneously later if you need to. The little bit of text that we're looking at off to the right there is a chunk of an actual Sanoid config file. The format is called TOML. Pardon me. It's pretty human readable. You can see we've got a storage pool and a data set, and we say we use the production template. Well, what's the production template? We define it right there. You can define your own templates and apply them. And that one says we're going to keep 36 hourly snapshots, 30 dailies, 3 monthlies, 1 yearly. We're going to automatically take snapshots and thin them. That's all you have to do to set all that up. You create your policy there, and Sanoid does it all for you. You don't have to have a giant laundry list of things in a cron tab trying to take all the snapshots at the right times and figure out when to thin them and get rid of them. Set your policy there, you're done. Now, since I actually wrote this presentation, I actually improved things a little bit. If I rewrote that slide right now, the next line on that pool dataset module would be recursive equals yes. You can now set your dataset definitions recursively, which means as you create more VMs underneath, pool dataset is a very generic name. Let's say it was data images instead. You could have data images Windows Server, data images domain controller, data images Ubuntu Trusty. On down the line, you might have 9 or 10 VMs on the one box, but you could just have the one policy definition that covers all of them under the one template. Automated monitoring. This one is huge. Again, as a small business consultant, I can tell you that in the small business world, and sadly in the mid-market world, and frequently the enterprise world, the way backups frequently work is that you have this awesome procedure, you have this policy that everybody follows with the tapes, and they do the thing every single day without fail. Well, maybe. But even if they do the thing without fail, it's never actually tested. So they've been doing this thing for 3 years, then you actually need to restore from tape, and you go to the tapes, and you find out that nothing has worked for like a year and a half, and nobody knew it because they didn't test it. Why didn't they test it? Because, to test backups from tape on one server is usually going to take you a minimum of half a man day, plus all the alternate equipment to actually do the restoration on, and blah, 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 blah. And ain't nobody got time for that. So the automated monitoring, we actually monitor our backups. We'll talk a little bit more about this later, but when we replicate VMs from a production machine to a backup machine, the nice thing about block level replication with ZFS, which is what Sanoid uses for storage, is you can't replicate half a snapshot. You can't replicate a partial snapshot. You can't replicate a corrupt snapshot because every single block of it is checksummed, and the checksum is validated on both ends. So if you got a new snapshot on the backup end, that means you backed up all your data. Yes, really, you didn't just wave the chicken, it happened. So if you monitor how new are your snapshots on your backup box, you are guaranteeing that you have backed up all the stuff on your server. And because this is a block level backup of a VM image, it's not a case of, well, I backed up the data on this one shared drive, but I forgot about the other one, or I forgot about the SQL server, or I forgot about the NoSQL thing that the devs installed and didn't tell anybody about last night. No, no, no. It's the whole image. It's backed up. No problems. So asynchronous incremental replication, rapid, granular, reliable disaster recovery, which we just talked about. Strong hardware decoupling. I mentioned this earlier. When you do Windows, and a lot of the things that I'm going to talk about here involve how much Windows sucks, and I apologize for that. I know this is an open source conference and we don't want to talk about Windows, but a lot of us have to manage that crap whether we like it or not. A lot of my goal behind building this platform to begin with was basically turning Windows into a self-contained little module and container that I could really finally treat as cattle and not a pet and not care about, because I could just, roll it back in time, replicate it from A to B, and basically not have to worry about fixing it and hacking it and all that other kind of crap anymore. So I mentioned before that, Microsoft says pretty clearly, although in very tiny print, system state restoration is only supported onto identical hardware. So one fix to that is you have an entire closet full of the exact same model of Dell server. A better fix for that is you just decouple it from the hardware and you lie to it. You give it virtual hardware that's identical no matter what the real hardware underneath the box is. My very first technically Sanoid, although the name didn't actually exist yet, platform for client was a CPA firm that had I shouldn't say they have a really bad habit of doing things like losing $5,000 install disks for Windows Enterprise Server. And so when they tend to destroy their machine, which they do with distressing frequency, it's always a giant pain in the butt dealing with it. Well, I deployed the baby version of this platform for them, and 6 months later, they had hired about half again as many people as they had originally. The hardware was an old Intel Q6600, if you remember those, which they maxed out at 8 gigs of RAM. Well, that was fine with their original number of employees. With half again, or double the employees, the thing was blue screening for lack of memory, and there was nothing to do. You couldn't add more RAM. So the fix here, luckily, since they were virtualized, since they were on this platform, I brought in a dual Opteron box with 32 gigs of RAM. I pulled the hard drives from the old one, stuck it into the new one, booted it, edited one text file so the NIC would come back up, and poof, all done. No restoration. Everything's just golden. So strong hardware decoupling, important. How do we do all this? So the actual virtualization part, it's built right into the Linux kernel. We use the Linux kernel virtual machine. I am a huge fan of KVM. There are a lot of urban legends rolling around about what KVM is or isn't, or what Zen is or isn't. And the fact of the matter is that the Linux kernel virtual machine, although it's usually used running in a full Linux host OS, and in fact, that's the way it runs in Sanoid, it is a high-performance, bare metal Type 0 hypervisor. Type 0 hypervisor does not actually mean that there's no host operating system, that there's just this little itty-bitty hypervisor and nothing else. It's not what that means. KVM also comes with some very useful uses for managing VMs. Storage, ZFS, and really, seriously, I don't know what I'd do if there wasn't ZFS, if that went away. ZFS was complete magic to me when I first started using it 6 or 7 years ago on BSD. ZFS is what makes almost all of the really awesome features here possible. The hourly rolling snapshots, well, those are ZFS snapshots. The offsite replication, well, that's ZFS replication, although greatly simplified. And what we've got here is an image. I'm trying to sum up how awesome snapshots are in one single screenshot. And if you can actually read it, we're looking at an Ubuntu file manager. And we've got, under the bookmarks, we've got Ubuntu snapshots on production. And we got an SFTP link to Ubuntu snapshots on the backup box. And we look, and it really kind of brings home what the snapshot really is. We've got automatic snapshot from October 19th at 9 a.m., at 10 a.m., at 11 a.m., at 12 a.m., and on down the line. And inside each of those snapshots, if you look at the contents, there's a QCOW2 file. Well, that QCOW2 file is the entire storage for that Ubuntu Trusty virtual machine. So that kind of sums up in one image that you are literally backing up everything every single hour, and it's in 2 places at once, which is awesome. So you light either one of those machines on fire and it does not matter because you have everything on the other one. So the best way to demonstrate all this is to murder something. Let's do that. We're looking at a video here of a virtual machine, a Windows Server 2012. And we start out firing that sucker up. And you can see it fired up pretty quickly. Just to demonstrate that performance is not an issue on this platform, we've logged into it now. We're about to restart it. I don't actually really like to talk about performance because performance isn't really all that important, although it grabs a lot of eyeballs, and people might have questions about performance on commodity hardware. We'll look at a Windows Server 2012 reboot. And 1.5 seconds later, we've gone from desktop to desktop. So if there were any questions about performance, let's just go ahead and put that to bed now. All right. I hate waiting on videos. I like doing these demo. So I actually have demo hardware out there at my vendor booth, by the way. So if anybody wants to see any of this stuff in person on the real hardware, you can come by later for that. And what we're doing right now is we're actually overwriting the storage for that Windows Server 2012 VM with zeros. Really what we're doing is watching me painfully try to remember the syntax for DD and PV and yada yada, etc. And eventually I'll remember how to type. This gets harder to watch every time I do this presentation. The problem is, though, it's not as hard to watch as watching somebody depend on Conference Wireless to do a live demo. So well, technically, we're living kind of dangerously right here because I'm overwriting about 16 gigs worth of storage zeros manually one by one. And because I'm a smartass, there's a clip from 2001: A Space Odyssey. If you don't remember that particular scene, Dave is pulling memory modules out of the computer and asking Hal to sing to him while he does it. And Hal's voice, yeah. So it's going to take our VM a minute to realize that I've murdered it, because although I've actually overwritten every single byte of its storage underneath of it, a lot of it's cached. So it's going to take a second before it actually tries to access something that's not in ZFS's cache, at which point it will promptly blue screen for us. Oh, there it goes. Yeah, pretty much. So the idea here really was just to demonstrate the fact that, I mean, we didn't just delete that file, like we seriously overwrote that thing with zeros. Every single byte of data in that VM was manually overwritten with zeros. And the reason that we waited through that process was so that you could see that, like, seriously, doing a rollback is no kidding instantaneous. We just undid 16 gigs worth of damage right there in that split second. And we are firing our VM back up. And we have unmurdered it. That's it. Now, imagine instead of me doing some flashy trick up here and overwriting it all with zeros, imagine that one of your users clicked the wrong link and the wrong email and found a lovely little thing called CryptoWall. And by the time you get called, half of your server, you don't know which half, has been encrypted with a key that you don't have. This is your procedure. Rollback. All done. All right, so replication. Replication is awesome. One of the things that we have, so we've talked about the backup, and we've talked about the snapshots, and we've talked about all this good stuff, but we haven't covered is, you know, what if the building burns down? And a lot of organizations will talk about, okay, well, it's just absolutely mandatory. We've got to have offsite backup. And that's about as far as that goes, because it's just not really practical for them. Or maybe, you know, you do something where, like, you contract with Iron Mountain to come get tapes, and, you know, of course you haven't verified the tapes, and blah, 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 blah. I like automated network backup, and that is what we're doing here. So ZFS all by itself has the replication that you need. The problem is that you pretty much need a master's degree to figure out how to use it. So I wrote a tool called Syncoid to make it very, very easy to replicate using ZFS's asynchronous incremental replication. And what we're looking at is a demo here. This is actual production data. This is one of my favorite clients. They're a civil engineering firm. They have, as you can see there, if you look, they've got 2.5 terabytes worth of data. That's actually 7 VMs, 5 Linux and 2 Windows with the 2.5 terabytes of data in them. And they have, as at the top, you see an iperf command right there. They have a whopping 1.15 megabits going offsite to their DR. So the next thing you see down there is me actually doing a replication from on-site to off-site using the syncoid command. Syncoid routed on-site images file server to backup file server. And it took a whopping, let's see here, 13 minutes and 36 seconds, which is about how long it usually takes. So their offsite box is actually in the upstairs den of one of the owners, tucked behind the TV where the kids won't see it. And as you can see, he did not go hog wild when he was purchasing his residential internet connection, but that's okay. 2.5 terabytes of data every night in less than an hour. All right, so putting all this together, talking about topology, how do we do all this stuff? What does it look like? What kind of equipment do we put in place? I'm sorry, go ahead. Is that any better? The problem is that sounds great here, but I don't think I'm actually on the mic hardly at all. I'm just super loud. Okay. All right. If you can't hear me on the internet, I apologize. So let's talk about actual topology. What kind of equipment do we actually put in place to make all this stuff happen? On our production network, we have a production host that runs all of our VMs. It's self-contained. The storage, the hypervisor, everything is all one box. Plug it in, done. No separate storage transport network needed or any of all that. It's a box. Plug it in, plug in your network, plug in your power, you're done with. Offsite, you have another host, ideally one that's identical to your production host. It doesn't have to be. You can get crazy and decide that, oh, well, I would have put in a slower CPU and less RAM, but more drives to keep more snapshots than I can on the one. You can do all that if you want to. In practice, you're usually probably screwing yourself if you try to get fancy like that. It's a whole lot better idea to just get everything identical and be done with it. So anyway, but you're replicating from on-site to off-site daily, possibly more. Depends on the bandwidth you have available and the amount of data you actually change every day. Pretty simple. But that's not really my preferred topology. That's like 2/3 of it. We can do better. So here, this is what I really like to do. We've got production, we've got a hot spare that's in the same site on the same network, and we've got offsite DR. Now, why would we want to have an on-site hot spare if we've got offsite DR? We've got snapshots, so for anything that's just like the data got corrupt, we can already roll back on the production host and undo the damage. And we've got offsite DR, for in case the whole building catches on fire or whatever. What do we want an on-site hot spare for? Well, the reason for that is, let's say that one of my least favorite hardware failures is the motherboard getting lunched. If the motherboard goes away on your production host, everything's down. And then you get to figure out, okay, where am I going to source the replacement motherboard? Is it the motherboard or the CPU? Yada, yada, yada. Let me go run down to the store, grab the stuff, unplug everything, unbolt everything, put everything back in, plug all the wires back in, tuck it all back up, blah, 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 blah. Real world, you've probably burned half a day in fixing that, even if you jump on it right away, like you were in the office right there on it in 5 minutes. So in a 20-person firm, if you're down for half a day, you just blew 80 man hours. If that's, for example, an engineering firm, then you probably just blew, many, many thousands of dollars on those missing 80 man hours. That stinks. So instead, you have your on-site hot spare. Well, now you lose the motherboard and your production host. You fire up your VMs from the most recent hourly replication on your hot spare. Your absolute worst case scenario is you have to recreate 59 minutes worth of work. So that's, 1 hour times however many men you got. But that's still going to be a quarter, I should say how many staff you've got. But that's still, a quarter of the damage that you would have done actually trying to replace that motherboard live and everybody's down while they wait. More likely, you're going to have less than a half an hour. So obviously it averages out to like a half an hour. So you figure you're going to be, half times 20, you're going to be down for 10 man hours instead of 80. That's a huge win. Now, another huge win about that is, let's say that you're, I don't know, maybe you're itself in another state doing a presentation up on the podium, and you get a call, holy crap, the server's down, and you see, oh man, the production host is gone, turn it off, turn it back on, that didn't work. Crap, what do you do? Well, if you got a hot spare, I can shell in from my phone and do verse start on each one of those VMs on the hot spare. It's up and running. It's on the same collision domain, same broadcast domain, so it's just up, all the same IP addresses, all the same everything from the user's perspective. They're just up and running. It works. You did it in 5 minutes, didn't have to drive anywhere. Everybody loves you. It's great. And you can go back to doing what you're trying to do, not, drive off to go save the day. So if you're a Latin geek, I probably got the grammar completely wrong on that, but that should be who watches the watchers. Right. So that should be who watches the watchers. And the answer is Nagios, and we use OpenVPN for connectivity, and Nagios actually watches all this stuff. So I mentioned before, my experience with backups has usually been that, you know, we wave chicken feathers every day, or maybe we don't, we forget to, but we at least plan to wave chicken feathers every day. And you don't really know if anything's going to be any good until you need it. And so then you sweat for a few hours while you try to do your poorly documented restore procedure and hope at the end of the day that you have what you needed. Screw all that. So we already know that our procedure is a lot simpler than that, right? It's easier to implement. We know that it just happens automatically over the network every night, and it's everything and yada, yada, yada. But I don't know, maybe maybe your ISP, I won't name any names, but maybe your ISP that goes in between your on-site and your off-site, maybe it goes down every night for like, you know, half an hour in between midnight and 1 o'clock, and that's enough to disrupt your replication job every night, which is supposed to happen at 1 a.m. And so you're not getting replication. Maybe that happens every single night. And, you know, like 6 weeks go by and you haven't had off-site replication, and then the building burns down. You're screwed, right? Well, no, that's what Nagios is for. Because Nagios, you see, we've got a plug in there that says Sanoid check snapshot freshness. If you have if your newest daily snapshot off-site is not under 28 hours old, you're going to get a warning. If it's not under 2 days old, you're going to get a crit. If you're a smart person, when you get a crit, your phone is going to start going bzz, bzz, bzz in your pocket. So the minute you aren't getting your backups, you're going to know about it and you're going to fix it right then. Nagios has your back. So instead of finding out when you need it and you don't got it, you find out as soon as it stops happening. Similarly, underneath that, you'll see we've got a plug-in Sanoid check storage pool health. You throw a disk out of your redundant array, bzz, 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 time to go fix it now, not when the second disk fails and you actually have a problem. Now, the cool thing about this, you know, I mentioned OpenVPN. If you notice the host name on here, demo.backup.vpn, so obviously, you know, that's a private domain name, private TLD.vpn. It's not publicly resolvable. However, that is a true, actual resolvable. I have a zone for that. If I want to SSH to demo.backup.vpn and I'm on my monitoring network, that resolves and I go there. I also have all my guests defined the same way. So at the end of the day, rather than having to remember, okay, well, it's like 10.38.142. No. You have like company name .machine name .vpn, and it's resolvable from your monitoring network, even if all these various machines are all over town or all over the world. As long as you're connected to your monitoring network, boom, shell in, RDPN, whatever you need to do. Do you have a question? So actually, your check storage pool health right there, every single block on a ZFS file system is checksummed. Every single block at the block level is checksummed. Every time you touch a block, it's validated versus that checksum. One answer to your question right there is you should have frequent scrubs scheduled. ZFS scrub literally just goes through and checks all the blocks versus the checksums. And if anything doesn't match, then it rebuilds it from parity or redundancy. Also, anytime you read it for any reason, every single time you touch any block, it's validated. And unusually for me, I think we actually got through with time to spare. We got through with a lot of time to spare. We have lots of time for questions. So either I'm walking off the stage looking like a scrub or you guys are talking to me. So, wow, that really didn't like being placed next to my phone in my pocket. Okay, so basically the answer for that is if you're the platform itself will let you do anything you want to do. It's commodity hardware. Now, what you should not do is you should not use like what you'll typically find in like, you know, Dell or Lenovo or whatever small business servers. Gotcha. I'm sorry. So the question was, what kind of storage adapters am I using in front of the disks? And the answer is, one, that it's your box, it's commodity hardware, you can do whatever you want. The second answer is what you should not use is you should not use cheap RAID adapters, or you don't want hardware RAID at all. You really just want simple storage adapters. The SATA ports that come on your motherboard, awesome. Cheap host adapters that are JBOD mode or IT mode, awesome. What you don't want to do is do like, oh, well, I have this, you know, super awesome like hardware RAID controller. I'll do RAID 6 on that hardware, and then I'll do ZFS on top of that. I mean, you can do it, but dude, don't do that. ZFS is better. If you do that, ZFS can't guarantee integrity because although it will still check some every block, it can't compare it versus other disks because it's not managing the array. Your hardware RAID controller is. And your hardware RAID controller will cheerfully feed you bad copies of data. So does that answer your question? Cool. So my favorite topology is a pool of mirrors. Yeah, the question was, what kind of storage topology am I using? Am I using RAID Z? Am I using mirrors? What? So ZFS, the way ZFS storage in general works is you have storage pool. Your storage pool contains VDEVs, which is short for virtual devices. A VDEV can be anything from a single disk to a mirror, two-way, three-way, four-way, etc., to an entire stripe with single disk, two disk, or three disk parity levels. You can do any of those things. My personal preference is for a pool of mirrors. A pool of mirrors is kind of like a RAID 10 for you old school storage guys, but the difference is that the writes are distributed across your pool of mirrors. They're not striped across it, which is much, much better because that means that a single read isn't going to hammer every disk in your entire array to fetch a single block. It will only hit the mirror that that block is on. Your rebuilds are way faster. Your IOPS threshold is much higher for pool of mirrors than it is for stripe. In general, what you want is as many VDEVs as possible and still achieve your parity goals. Correct. The Nagios plugins that I wrote, they're Perl code and they exit 0, 1, or 2 to say okay, warn, or crit. Does that answer your question? Fair enough. Sure. So the open source part is everything. There is no proprietary code involved in this at all, period, bar none. If your goal in life is just to go grab the code and download it and install it and put it together to your liking and run it and you build the hardware and you manage everything, you are welcome to that. I am a big believer in the concept that your customers are people who want to do business with you and find value in giving you money in exchange for goods and services. So the business part of it for me is there are a lot of folks who don't want to manage all that themselves. They don't want to have to make those decisions. They want to leverage the fact that I've literally been doing this for 6 years longer than anybody else on the planet since it's my platform, and get vendor certified hardware, get support, get monitoring all built in at a decent price point. If that's you, you are my potential customer. If you're like, well, I don't want to give that guy money for all that stuff, I just want to do the thing. Well, do the thing. You're your own customer. That is different for every application. My personal preference is okay. Is there a sweet spot for solid state storage versus Rust? And the answer for that is it's different for every application. If you can afford to, all of your storage should be solid state, which really doesn't have anything to do with this platform. That's just a fact. If you have a few hundred gigabytes of data and it's on Rust, you're doing it wrong. Stop that. Go buy solid state drives. On the other hand, if you have 96 terabytes of data and you're not made of money, you're probably going to need some Rust. In that case, usually my answer for that is going to be to have multiple pools. You have a solid state pool and you have a Rust pool. Put your boot disks on solid state, put your databases on solid state, and your bulk storage should go on the Rust. Let me take over for you real quick on that one. If you want to do like an actual tiered storage kind of a thing, so ZFS has built in something called the ARC, which stands for Adaptive Replacement Cache, which is a very advanced caching mechanism, much more so than Linux kernel's IO cache or Windows IO cache. Both of those are FIFO first in, first out. So if you read 10 gigs of data and then you hit that 10 gigs of data in your cache 500 times in 5 minutes, and then you read 10 new gigs of data, it will push that first 10 gigs out, and you got to read it all again from the platters as soon as you want to access it again, because it's just FIFO. The ARC is not FIFO. The ARC weights the blocks in the cache by how many times they've been hit. So if you read a block and it's in cache, but you never asked for it again, it's the first one to go. That already is super duper awesome, and is a lot of the reason why we see things like 1.5 second reboots on Server 2012 R2 VMs. While that demo was done on solid state, honestly, it would have looked just as fast on Rust, because really it wasn't that fast because solid state. It was that fast because every single block of that was coming out of cache. Now, if the amount of RAM you have available to you isn't sufficient, in your opinion, you can do something called an L2 ARC. That's level 2 adaptive replacement cache, which will build more cache onto a solid state tier. However, that is very much a specialty topology. Don't get crazy with that. It usually isn't what you want. You need a lot more RAM to actually index and manage the L2 ARC that then isn't available for the real ARC. You're usually much better off doing what I was talking about and split up your storage into multiple pools. Do your high IOPS stuff on a solid state pool. Do your low IOPS bulk stuff on a Rust pool. There's also there's something called the slog, which is so there's the ZS intent log, which is in RAM, much like the ARC is, and that's a write cache. You can do a slog, which is a separate log device, which also can be solid state, and you can buffer your writes to a slog. Again, if you have a really specialty application that can do good stuff for you, in practice, 99.999% of the time, it's a boondoggle. Don't bother. Keep it simple. Anybody else? Yes, sir. Okay, so the question is are we managing compute intense workloads versus storage intense workloads versus memory intense workloads? And the answer to that is, well, to paraphrase the late Steve Jobs, manage differently, scale differently. The idea here is that rather than your traditional enterprise virtualization stack, you have an extremely tall storage silo, you have an extremely tall compute silo, and you try to just kind of cram everything on there and then have policies to manage them all differently. The way that you scale with this platform is you're never going to have more than 10 or 20 VMs per box typically, and that's a good thing. You could in theory build a really crazy box that would run more things than that, but you're probably doing it wrong. The way that you scale is you just stack more things on top. So in general, if you have some storage intense stuff and some RAM intense stuff and some compute intense stuff, you put them on different hosts and you manage those hosts differently. You treat the whole thing as a building block. If you buy into my three-way topology where you've got an on-site production, an on-site hot spare, and an off-site DR, well, that's 3 boxes that are a unit. That's all your replication, that's all your hypervisor, that's all your storage in one unit. You throw some VMs on there, they're managed like that. If you need more VMs, then you get another bunch of 3 and you put your more VMs on those and you manage those however you need to. Kind of building on that, I frequently get the question, okay, well, that's great for small business, but how does it scale? I work in a data center. What if I want to manage hundreds or even thousands of VMs? And the answer is, well, how do you do it now? Which the answer to that is usually CloudStack or OpenStack or, whatever. Maybe I deploy with Salt or Ansible or Chef or Puppet or blah, 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 blah. Don't change any of that. You already know how you manage hundreds of VMs or thousands of VMs. Keep doing that. You put this stuff underneath it, and it gives you the replication part and the snapshot part that you very likely don't have on the underlying hosts that you're using underneath your stack management software right now. This is actually a pretty hot topic, not with my platform specifically, but if you want to geek out on all this stuff, like I said, the industry buzzword is hyper-converged infrastructure. A little bit of history on that. Converged infrastructure you would think would be fine. Why do we need to throw hyper in there? That's because some vendors started selling Hitachi SANs and 10 gig fiber switches and blah, blah, and whatever, just selling it all on one invoice and calling that converged infrastructure, even though it was the same old crap. So now I say hyper-converged to let you know, no, we're actually condensing this onto a single self-contained box. The big player in this space is an outfit called Simplivity. And they basically do the same thing that we just looked at, but every single bit of it is proprietary and pretty high dollar. And they're not focusing on small business. They are focusing on the data center. And the big pitch is, just like what I said, you scale by just adding more boxes and putting stuff on the more boxes, which is much simpler to manage. And also, you're very much compartmentalizing the damage that a rogue VM can do. Yeah, if you have the traditional really tall storage stack and compute stack and whatever, okay, well, I set policies to limit the IOPS from this VM or that VM or whatever, but you've still got one big complex web of crap that can go south on you. Whereas if you've got all these self-contained boxes with 10 VMs or 20 VMs a piece on them, you've limited your damage. If a rogue VM starts really thrashing your IOPS and does it in a way that you haven't, maybe you didn't see a way through to limiting the IOPS, because I mean, you can still manage that kind of stuff with, you know, the tools built into the kernel. But if you didn't do that in every way that you might have needed to contain the one person who did the really stupid thing, it's only going to impact those other VMs on that one box, not your whole data center. Gentleman said he believes that Cisco UCS is the biggest player in hyperconverged infrastructure. What you just described is actually the old converged infrastructure, where basically one vendor sells you all the crap in one. It's not hyperconverged because it's not individual self-contained small-scale things like this. It is the old school, like we have a whole rack full of crap and lots of stuff depending on a fairly tall silo. That's converged infrastructure. It's being sold as one piece, but you've still got a pretty tall silo and you've got a fair amount of complexity managing all of it. Even though it's sold as one piece and it's maybe in one rack, it's not down to what we're talking about, which is just self-contained individual boxes that buy more boxes, and that's all there is to it. It's I'll grant you it's a little bit of a fine distinction, but if you actually go looking at, you know, the VC stuff, that's where they draw the line between converged and hyperconverged. Anybody else? Anyone? Bueller? Well, thanks for coming out, folks.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and Disk Writes and Free Space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.